We have today two topics. First topic, intensification of anaerobic digestion of wastewater and sludge, some trend analysis, and the next also topic with connection with this topic, modeling of biofuel production according to some climate change adaptation technologies, and also some discussion of bioenergy. So today we have these two topics with some connection between each other. And now I think we start our first part, and should be mentioned about content, because mostly we can tell about anaerobic digestion as a process for recycling different type of organic waste with production biogases, biofuel, yes. But also it's type of biological treatments that can be very useful for purification wastewater and detoxification of sewage sludge. So it's also very important to see this how to say approach for treatment, anaerobic treatment of wastewater and sewage sludge. And we discussion today some composition of wastewater and sludge, how it can be implementation anaerobic digestion, some technology of pretreatment that can be useful for stimulation aerobic digestion. And interesting part is problem of pollutants in wastewater and sewage sludge, and how we can use biological mechanism to fix it, this pollutant. Example is heavy metals, and analysis opportunity for co-digestions. So this is our content, and we try step by step analysis all of this information. And let to see if you have some question, you can ask me, you can text me, so it depends of you. And also, if you have some problem with sound, with translation, my presentation, also please tell me. It can be some internet instability or some technical issues. So please, if you have some issue, have you something misunderstanding, please text me or tell me. It will be good. So all type of feedback very important for me as lecturer, because I need to analyze how this information you suited for you, fit for you, that you understand this information, how it's interest for you, how it can be possible to discuss some of more aspects from our lecture. So all of moments we can more deeply analysis together, but I need to know your opinion. Okay, so first of all should be mentioned, it's also very important opportunity for biological treatment in wastewater treatment systems, because it's a really important part of purification of wastewater in municipal wastewater treatment plants is biological methods, and often applying aerobic conditions methods, but also anaerobic can be useful. So we have two type biological methods: aerobic with oxygen and anaerobic without oxygen. And both of these biological methods can be useful in applying in wastewater treatment systems. Today we have such focus in anaerobic treatments. Wastewater existing active sludge, sewage sludge on settle site. So it's mostly three types of how to say, we can tell as resources and feedstock, most of all, that can be used in anaerobic digestion for production such useful products. It's mostly biofuel. We can tell about biomethane and biohydrogen, and also about biofertilizer. So it's mostly very interesting potential for such type feedstock. So we tell about this mostly as waste, yes, wastewater, this activated sludge, mostly activated sludge go from aerobic biological state of wastewater purification, and it can be, how to say, useful also, but sometimes it's only go to sill sites for deposits and not use. So it depends how we can recycle this activated sludge or not. And also search sludge is accumulated in the field, in the landfill, so it's also not used very effective. But anaerobic digestion give us potential for recycling this type feedstock. And also we need to understand how we can recycle that feedstock more environmentally friendly way, because of course they can have some toxic components, some pollutants. Okay, type of wastewater we can, how to say, devoted to separate groups, for example, domestic wastewater, industrial wastewater. Some type of pre-treatment of industry wastewater can be in industry wastewater purification systems. And mostly it's together go to municipal wastewater treatment system and municipal wastewater treatment plan, where they have a different type of state, including biological purification for treatment. Also, it's important organic load in this type of wastewater. It's important for biological degradation processes. We can estimation biological oxygen demand, representative of amount of oxygen consumed by bacteria of other microorganisms that can decompose this organic matter. And this is type of parameters used in aerobic condition. So it's an oxygen present condition. Mostly it can be discussed some of typical results for this parameter estimation and analysis how this water is have organic load and very big or not, and how it's processing of purification. Especially when we tell about activated sludge, of course, it's very important for biological treatment. Activated sludge can be aerobic activated sludge. It's from aerobic biological treatment, and anaerobic activated sludge is from anaerobic condition. So can be two sludge in municipal wastewater treatment plant. Mostly we have aerobic activated sludge that use in biological treatment in aerobic condition for biodegradation, complexes, organic contamination of wastewater. So it's also estimation some macro biodiversity of this activated sludge, because it's involved different groups of microorganisms that in the trophical level, different trophical level, that can be used step-by-step consumption, different type of organic pollutants. And of course, we estimation this composition, estimation some of dynamic of population of different microorganisms, and it's so very important for monitoring of activity of this sludge, activated sludge, how it's effective use for purification or not. Other type of our feedstock is sludge. In general, that located in lands and mostly how to the storage of this sewage sludge in big territory also have some environmental issue. Yeah, of course, this sewage sludge can be useful because they have nutrients that can be interesting for agricultural application. But also, this type of stock have some harmful components, especially heavy metals or carbohydrates. Some oil pollutants can also be present. So it's important to analyze the dosage of such sludge that can be useful for land application in agriculture. And also, if we have such big contamination sludge, for example, heavy metals a lot, so we need to fix this type of contaminants in some stable form that do not migration in ecosystem. So all of this very important to apply sewage sludge effective apply in agriculture. So now it's a lot of technologies, innovation according opportunity of use wastewater and sewage sludge and anaerobic treatment. And for this also we have different stage of treatments that can be useful for intensification bioprocesses and increasing biogas production. Technologies of pretreatment we can devote it to increasing of rate biodegradation of organic substance, organic pollutants, and increasing the use of some type of mineral supplement, chemicals, byproducts for intensification processes, fixing heavy metals, for example, is very important. A pretreatment can be different, and for disintegration organic complexes we can use mechanical disintegration, thermal disintegration, cavitation, different type, and disintegration with ozone that can be useful for reduction digestion time. Also better sludge watering, of course, increasing biogas production, mostly also decrease of amount of volatile total solid in the digestion sludge. So all of these opportunity very important for pretreatments, estimation effective of pretreatment. And of course, also we can analysis this intensification according some of features of realization this process in this context of engineering part and context of biological part. For example, to use some different microbiological stimulation, some stimulating additives, selection of microbial cultures that can be dominant under anaerobic digestion. For example, some methanoganic consortium and some other type of chemical, physical treatments that can be useful for disintegration organic components. And mostly one of examples that a lot of now discussion involving electrolysis for increase methanogenesis, and also it's important for organic oxidation processes. It can be possible estimation economical parameters, feasibilities of these processes, because it's involving additional energy sources, but also this estimation very important for parameter decrease time of treatment and increase it twice as level of biogas production, so it can be benefits. Ultrasonic treatment also very standard using for some type of sewage sludge pretreatment because it's improving aerobic decomposition and also improving ratio carbon per azote for denitrification processes. So it can be useful also. Our investigation of impact ultrasonic treatment for substrate. We mentioned sludge, for example. For anaerobic digestion, we can analyze it according to some particle of size of the substrate that can be we get after ultrasonic treatment, and it's really impacted for level biogas production because it's more suitable for microorganism growth and metabolic activities support. So quality of composition also can be changed. Microbiological stimulation can be really different. A lot of investigation now in the context of enzyme addition, improving the sludge decomposition, increasing methane production. Mostly biogas, we tell about composition of biogas, and methane is a basic component, and we need to increase methane in biogas. It's very important for energy purpose. About some syntrophic relationship microorganisms, some of investigation of this type also present in such type of pretreatment and biostimulation preparation. Another way, it's a hydrogen addition that we tell about. Electrolysis also is some of the techniques that use. Mostly we can tell about magnetic treatment. It's also one type of pretreatment. It's not that a lot of use in practical. They have some positive effect of magnetic field for increasing in biomass and metabolic activities, but also negative impact can be some type of damage of cells membranes. So it's also different type of research to tell and give different results according to some parameters of this magnetic treatment, and it's that discussion of the type of effective use magnetic treatment in this way. Most of all, when we tell about sewage sludge that deposit inland and activate sludge, activated sludge, it's important analysis how we can improve composition, because a lot of heavy metal presented in industry wastewater, for example, and they go through a system of treatment in wastewater treatment plant, go to sewage sludge, for example. So heavy metals presence, and we need do something with these heavy metals because it restricts for applications sewage sludge in agriculture. Deposition heavy metals by biogenic hydrogen sulfide, some of the interesting opportunity for this, and this method mostly have a practical implementation. And this is also an important question about quality of composition biogas. So study of the optimal ratio of different types of sewage sludge and how it's impacted of biogas production, and what type of method we can use for fixing heavy metals. Unsolved form, very important. We can analyze this as composition according combination ratio sewage sludge with excess activated sludge, and analysis the more suitable composition, and also how it's impact for biogas composition, biogas production, because it is important to reach a more high level of methane. And of course, when we tell about anaerobic digestion, this feedstock, we tell about production of fertilizer. based on digestator and microbiological degradation, such as with precipitation heavy metals by hydrogen sulfide can be interesting in this way. What we can tell about hydrogen sulfides? Most of all, the firstly that we tell about anaerobic digestion, it's work different type of microorganism in anaerobic digestion. They have state hydrolytic degradation, some basic big organic components for yes, it's a pure state. Then it's the henic state. With volatile organic acid and metagenic state is the terminal state when involved with metagenic archaea for production methane. But mostly in this state also can be present sulfate reduction bacteria. And these bacteria in metabolitic products is hydrogen sulfide. Hydrogen sulfide not useful for quality of biogas, but we can use this hydrogen sulfide for precipitation heavy metals. As this interesting biological mechanism can be employed for detoxification through sludge and wastewater. So we estimate solid fraction after anaerobic digestion to analysis the main mineral composition. You see some present diffractometers results as a basic part of minerals elements and also metal present in sulfides form. It's important. So heavy metals precipitation with hydrogen sulfides to metal sulfides. This type of components fixed in a form that not can reach plants, for example, not migrated in ecosystem. So it's important precipitation these heavy metals and estimation effective of this precipitation and analyze it. For example, what type of mineral addition can be added under anaerobic digestion to sludge for intensification processes by precipitation heavy metal. It's important to know this optimal range. For example, we can use such mineral addition, chemical addition as phosphogypsum. It also should be mentioned about phosphogypsum is chemical waste from production chemical fertilizer, and the basic component gypsum, but they have also some addition. And also recycling this type of biochemical can very interesting, and we need to something to do with phosphogypsum. So possibility to involve in this type of mineral addition to anaerobic digestion for precipitation heavy metals can be interesting. So it depends on substance that we use. And after anaerobic digestion, organic halide complex with heavy metals were destroyed and formed stable components of sulfide. So it can be useful. So it depends on the stock that we have and what type of anaerobic digestion we need. Anaerobic digestion for get more basic biogas production with high level of methane, or we need focus on detoxification under anaerobic condition, this feedstock. Also, we can analyze the opportunity of co-treatment, co-digestion. And now in this slide, you can see some of stimulation using was viewer software and data that we use for the stimulation we get from Scopus database. It's sort of statistical dates, bibliometrical dates that we get on the topic of co-treatment, different type of waste. For example, food waste, co-treatment with wastewater. Now it's sort of a discussion topic of combination different type of substrate, different type of feedstock, and how it's possible. And we analyze this side type of combination and mechanism that can implementation under these processes. This cluster modeling, we can see clusters in different colors with focus of some of most important relevant trends under this type of research activities. For example, evaluation of use some of type wastewater after anaerobic digestion in agricultural sector, implementation, and how we can see some of implementation integration wastewater treatment in combination with algae cultivation and food waste processing. So it's an integration system that can be analyzed using such type of software. I think this result of using this software we can see also in other presentation in the second part of our lectures. Most of all, I recommend it if you're interested into analysis a lot of dates, bibliometric dates that you get from database Scopus and Web of Science. Recommendation use some of type of software that can be useful for modulations. It's trends of analysis of most interesting implementations. This type of treatment in the world or some regional level. That depends of focus of your research. The next that should be mentioned that also some of resources with implementation and municipal wastewater treatment system also proposed selection of organic fraction of municipal solid waste and processing in sludge treatment systems that can be also a type of co-digestion use. And of course, a lot of combination now presented that use two type of biological treatment: anaerobical without oxidant, anaerobical treatment with oxidant, and the fixed anoxygen treatment also. So it's a side type of opportunity to combination different biological treatment for reach the most effective dephosphatation, the nitrification, and also to get some of benefits and production by products, by basic products, that biofertilizer and biofuel. And this approach also different type of combination can be used. Mostly this collected some of approach in European Union standards that mostly have technology attributes according to the treatment, water quality, footprint requires, because a lot of in the European Union tell about footprint family and how we can estimation some of technologies and using a methodology of footprint family, and it's also according some of wastewater directives that connected also for improving list of pollutants that use in wastewater treatment system. A lot of discussion about nanopollutants, but we're not involved to this under this topic. We mentioned about heavy metals, yes. But a list of pollutants grows rapidly, and identify new pollutants. And also when we identify these new pollutants, it should be some techniques that can be really applied practice to identify in the cities type of pollutants. So in a wastewater treatment system, it's also a lot of discussion for monitoring process and soon for applying some techniques of purification. Also tell about biogas recovery and efficiency, water recycling efficiency, liquid fertilizer the efficiency, most of all when we tell about anaerobic digestion and to get digested as organic fertilizer. Yes, we tell about solid and liquid fertilizers that we can get and also apply in agricultural sectors. And it's also can be discussion, especially when we tell about such type of feedstock as wastewater and sludge. So that can have some of harmful components. And in this way, it's important to estimation some of potential risk to imply in agricultural, and how we can reduce this risk, how we can have some pretreatment, precipitation, some removal harmful components, and estimation dosage of involving this type of fertilizer to agriculture. So it's a lot of different approach. The most conceptual model involved zero waste system, and also evaluations and recycling methods and life cycle assessment. I tell about life cycle assessment previously. This methodology widely used in the European Union countries for estimation how it works. It's also implementation different technologies, and of course it can implementation in wastewater treatment plant for modernization and involving to such zero waste approach. It's a mostly important part of this type to mention opportunity to integration system of digestion, different type of co-substrate, different type of feedstock together. And now a lot of discussion how involved more different type of substrate for this, and this substrate is mostly different type of waste. Yes, we tell about sustainable feedstock, and for mention for ourselves that it can be possible to involve in different type of waste. So reduction to use natural resources. It's very important for such type of technologies growth and realization sustainable development goals. So we tell about the discussion previously. So it's a very important part for analysis these technologies and how we can intensification anaerobic digestion. Previously we tell about this technique, so it's also important to evaluation opportunity for realization these techniques with involving analysis of impact to environment, and also all of byproducts that we can get from this system. We need an evaluation how it's impact to environmental components, how we can use it, how it can be effective go to market and consumption. So it's all a package we're using an environmental assessment, economical assessment, social assessments that I mentioned. All of this part should be done, and mostly when some of project, for example, preparation for grants, its difference can have level grants. For example, a lot of today tell about Horizon to Europe, and etc. Also, it's important as the basic of analysis and provides them good analysis of implementation approach that description is this project and estimation evaluation model of impact of implementation this project for environmental, for economic, and also for society, how to say, how it's impact for human life, and mostly all of these categories, implementation with life cycle assessment, very important, not only some scientific innovation level, but also very important this description and involving some industry, some companies that really want to scale in these products, this technology, and implementation in industry level. So it's all components that can be involved together, and when we tell about some of aspects of investigation processes, stimulation process of anaerobic digestion, for example, digestion, different types of substrates, especially substrates that have some toxic components. It's very important estimation all of state of treatment with analysis of parameters and all resources that involve into the system. Accordingly, such environmentally friendly approach. Yes, is this the first part? You also, if you have some of questions, you can ask me. It's up to you. And we can discuss some of part of this presentation, of the next presentation more deeply. And next part, maybe we can also discussion, because I have several presentations that involved mostly the topic anaerobic digestion, anaerobic waste treatment process in a different way. Because we can tell not only about anaerobic digestion to get biogas production, but we can tell about dark fermentation and biohydrogen production. Now, it's also such topics that a lot of discussion. Biohydrogen, hydrogen is such more clear energy sources, yes, and dark fermentation, it's also treatment in anaerobic condition. So it's have some of connection with anaerobic digestion. So it's some moments that we can tell if we have time, but now we go to presentation, modeling of biofuel production and climate change adaptation technology. So now I try to share my screen, and we can see this presentation with this under this topic. Okay. Okay. So you see this presentation. If something wrong, if you don't see some slide because can be different technical issue, please tell me. Now we on the slide of content. We analyze briefly, briefly trends of the production of different type of biofuels, some method of production biomethane, also discussions about opportunity of biogas purification using biological methods, and some of modeling of hydrogen sulfide bioxidation, also with production elemental sulfur. So, and I think in this way we also go to some of website with this technologies realization. I show you some of video. So when we talk about adoption technology, we can go to some of climate change reports that give us some of definition. So about what is mean adoption technologies, application of technology in order to reduction of vulnerability, of enhance of resilience, and also of its natural human system impact of climate change, its impact of how to say very important tell not only about climate change, it's a lot discussion now, but mostly this change we see is current, and now also a lot of proposal how we can adapt it to this change, and mostly it's also connected with growth level of biotechnology involved in the market, and it's connected with possibility of use different type of sustainable feedstock is a biomass, and also using different type of renewable energy, especially we tell about bioenergy, and possibility of current generation, for example, projects. So it's development of infrastructures and conditional biomass collection infrastructure is also important in this way. Priority of growth by energy levels involved into energy sectors, economic. Visualization of clusters that we can see also using was viewer software, stimulation and aerobic fermentation. Yes, these two type of keywords. We can analyze some of most target how to say direction of research and implementation this research in the world. We see 3 clusters that involved first of all technologies of enzymes treatments, how to say it's for biostimulation, microorganism growth. I mentioned previously in previous slides presentation about opportunity of stimulation anaerobic digestion, and also tell about various of biostimulants that can be used for this. So it's one of type of research in this field about green cluster associated with some of basic fermentation processes using combination of aerobic and anaerobic treatment of different type of substrates together, and also method of genetic modification of microorganism. Mostly genetic modification can be present in aerobic digestion, but it's also discussion of this type of opportunity involving to process anaerobic digestion modification groups of microorganisms. It can be effective, but it should be analysis consortium of microorganism and state that we involve in this type of genetic modification bacteria, for example, to anaerobic fermentation processes. So it's mostly now how to say have such type of traditional classical growth level of engineer construction opportunity for stimulation anaerobic digestion, and other way it's a biological part and involving some mechanism to increase in level of methane production using some techniques and tool genetic. So we can go to the next slide and see some possibility of growth priority of bioenergy strategy and integration, some integration process of organic waste for production biomethane, very important. And production biomethane, it's mean that we can do, how to say, to reach some more big level, more high level of methane in biogas. purification biogas to biomethane. It can be different technique to get this. When we tell about biological process, because purification biogas, for example, or to enrich biogas to biomethane can be also using chemicals, physical methods, membranes methods for this, but also biological methods presented, and also have some industrial application. And today we tell about this time because we tell about biotechnologies realization. And for this, we can analysis of use some biological oxidation. If you remember last presentation, we see heavy metal precipitation use sulfate reduction bacteria in anaerobic condition. But in this presentation, we tell about sulfur bacteria that can how to say use biological oxidation processes to get sulfur, elemental sulfur from hydrogen sulfate transformation. So it's also interesting because we can purification biogas to remove hydrogen sulfide and to get more high quality of biogas, to more rich to biomethane, and also to get elemental sulfur that can be useful in agriculture. And now we can, how to say, go to one website. It's a website of some how to say companies that provides this sort of bioreactors for purification biogas and using these biological methods purification. Maybe we go to site now. I sharing my screen. Some moment. First of all, I need to choose the most important. Choose the right window. Okay. Some moment. Yes, you see now this website. I hope you see. And now I want sharing video. If you see this video, biological processes for the removal or recovery hydrogen sulfide from gas streams, you can some in chat text me that all okay. Or if you don't see it, also please tell me. And now we can see techniques, biological processes for removal of hydrogen sulfide. It can be different type of gas streams, such purification, not only biogas. Mostly it's such environmental friendly technology. So 3 simple states we see. First stage. Solutions. Absorption system. So we need hydrogen sulfide solution to liquid fraction. First of all, go to liquid fraction hydrogen sulfide. So is the bioreactor the next stage, where we see, how to say, Teobacteria for oxidation, hydrogen sulfide and liquid fraction. And this dewatering stage, the final sulfur cake we get. Buffer system, alkaline should be, how to say, stabilization, how, let's say, also important in liquid fraction. You see found bioreactor. So mostly it's that filtration system. And the gas streams go through this, go to all of the system, go more clean gas go up, and then we go to liquid fractions, they go to bioreactors, all biological processes in a liquid fraction scene. And solution with sulfide go to these reactors. First of all, is the aerobic condition should be mentioned, and we see this bacteria. Mostly the bacteria consumption sulfide in grows biomass of this bacteria, and mostly we can get these products as sulfur. And we can get elemental sulfur, mostly it's out of suppression system, gravity settle in the phenol, and we can get this sulfur, elemental sulfur. I can also give you this link to video. If you're interested in this technology realization, you can check in this website. It mostly this three-stage this technology used to product this elemental sulfur that can be used for, as a fungicide and fertilizer. Component of complex fertilizer can be used sulfur. So it's that industrial implementation of biological purification of gas streams, and these techniques also can be used for purification by gas to remove hydrogen sulfide. So it's type of technologies used in industry, and I can share in our chat. We have some chat. I think you see this chat. This link. If you're interested, you can for yourself also check this information. Mostly this technology have different type of improving. Some of how to say, to different type of realization, nuance, engineering aspects, but mostly interested in how it can realization in practicals, and it's interesting such type of example of realization. engineering factors impact. We mentioned about this engineering part when we tell in the previously yesterday, yes, about some elements of biotechnology that involve in general to biotechnology, because biotechnology solution can be very different, but nevertheless we have some of more basic state elements that should be in biotechnologies. And of course, engineering part, equipment that use all of state, very important. And now we see two factors of stimulation, intensification of anaerobic digestion, for example, using construction engineering factors and using some biological factors for biostimulation of anaerobic digestion. So it's can be together discussion, together analysis, this type of intensification processes, and also it's involving how we can tell about climate adaptation technologies when we tell about biogas production and anaerobic digestion, because the process of anaerobic digestion, we can reduction of different types of organic waste. Also, it's can useful when we fix it some for example CO2, yes, and it's not go to air. We can also use CO2 and use methane as natural resources. We use methane. CO2 can be used in greenhouse techniques plant, yes, for growth plants. So it can be useful for decrease carbon footprint and also involving as techniques and technologies for climate change adaptation. And when we tell about the opportunity of bacterial oxidation, for example, hydrogen sulfide, we also can use different type of immobilization materials for bacteria's growth. As I mentioned previously, we have investigation of that type chemical waste as phosphogypsum for different type of biofilm growth, and not only in anaerobic condition but also in aerobic condition. And this type of study mostly for me, how to say, very important, because I have a lot of how to say background of this chemical based cycling, and now when we tell about opportunity of immobilizing different type of microorganism in the bioreactor system to get more good quality of biobasic products, it's also important to analyze the opportunity or use different type of feedstock for this. Not only tell about organic waste, but tell about some other type of waste, chemical waste. It can be also useful for bioprocessing. And in this type of example of opportunity of use components of chemical waste with how to say benefits use in bioproduction. As example and as case study, we can tell about phosphogypsum, very small some introduction I can give you for this type of waste. Most of all, it should be mentioned phosphogypsum located in different regions in the world, and it's issue not only for some countries, but a lot of countries have such a question what can be do with this phosphogypsum. And also it should be mentioned quality of phosphogypsum depends of raw materials that involve in the technology of fertilizer production, and also technological factors impacted of composition of phosphogypsum. But basically we can tell about some of components phosphogypsum that can be useful for microorganism growth, as sulfur, calcium, some of trace elements also can be useful, and this way can be discussed together with other opportunity for recycling this type of chemical feedstock. And now we can tell about opportunity of phosphogypsum recycling in different country. It's also Ukraine also have a lot of this type of waste and phosphogypsum dump in different regions in our country. In some regions, for example, more than 15 million tons of this waste. In Ukraine, more than 50 millions, 50. In some 15. Only located in our territory region. So mostly it's a big volume, and also it's generation in chemical industry. So it should be something recycling can be possible. And in other country, for example, with collaboration from partner with Germany, organization, research organization, and also Poland, Italy have some of interest in of recycling such type of phosphogypsum in different way, because now it's a target topic involving different type of secondary resources as sustainable feedstock for industrial production, useful products. And question, for example, in this research connection with biochemical purification biogas to reach more big volume of biomethane and removal hydrogen sulfide using some immobilizing medium that can be involved in phosphogypsum granules. Of course, realization of biotechnologies with biogas production, we see it's important the energy purpose. Also, it's important quality of biogas and to how we can use these components effective and to get more profits, more benefits for our technology solution. And in this, we need discussion some limitation of biochemical reactions, some of inhibitors of processes that can be for study of kinetics, and analysis opportunity of get more benefits of use some minerals, some byproducts, chemicals, byproducts and waste as a potential feedstock and potential immobilizing medium for biofilm growth. Should be mentioned that now minerals carrier for immobilizing microorganisms is a large field of research that have different type of application in industry, because immobilizing microorganism in some mineral carrier, in some fixing, it's mostly fixing in some materials, help us to have some positive effects for growth bacteria in this biofilm, more strong adapted to the medium and around this biofilm form it to be because when we tell about purification system, it's also some of type of aggressive condition can be. And when we tell about a flower that goes through these bioreactors, also it's important fix this microorganism that not go together with this flower with or general output from system with water or with some gases phase, with solid phase. So this biofilm should be in this bioreactor and work well. So it's also important, and immobilizing materials can be very different. I think if we today have time, we can also more deeply analysis opportunity of this type of materials, immobilizing microorganisms, because its techniques, in general, these techniques can be used in different biotechnologies, not only for biological oxidation, hydrogen sulfide, but also in anaerobic digestion treatment, in composting system, also can be used different mineral carriers for mobilization microorganism. And of course, when we tell about biopreparation, that can be used in agriculture, also useful groups of microorganisms can be mobilized in some materials before involving to agricultural application, to land application, and it also can be useful to effective uses biopreparation, and for example using biopreparation for removal oil contamination from ecosystem components, also using different type of mineral carriers can be very effective for growth this microorganism, adaptation to aggressive factors, environmental, and for purification ecosystem in general. So it's some basic information, and also should be mentioned a lot of investigation of processes matrix, different type of matrix used for cell absorption, and now investigation difference research schools, and also have practical implementation in different field of biotechnology, industrial biotechnology. Now, most of all, when we tell about biogas technology, not only biogas technology, but when we tell about anaerobic digestion stage by stage, we can to get some of useful products, not only, for example, biomethane, but also biohydrogen. When I mentioned about dark fermentation, I think we have time I tell more about biohydrogen production, and also to get they start as fertilizer and sulfur after biological oxidation hydrogen sulfide. We can get these products as sulfur we supply in agriculture, that I mentioned before, and we see a video about this technology, such type of technologies. We can see that we can get more useful products from this system, biotechnology system. And application of sulfur as sulfur-based pesticide or fertilizer production can be also interesting, and a lot of different type of sulfur forms discussed, more suitable sulfur fertilizers, and we can analyze some of factors involved in this sulfur to the soil, and how it's can impact of agricultural and mostly in general system when we tell about hydrogen sulfide and anaerobical and aerobical condition for conversion this type of sulfur components. And of course, modeling of the system by farm oxidation capacity curve can be estimation and analysis sum of change in hydrogen sulfide concentration by gas. That's also very important for analysis the effective implementation of this technology, or how we can improve in this optimization time or treatment time, and etc. Sulfur oxidation bacteria is also a lot of investigation of some of basic metabolic pathway, biochemical consequences for this processing. A lot of investigation. This using different type of bioinformatic databases can be possible. We will not mention a lot about this, but mostly these techniques using different engineering equipment, for example, trickling filters can be used for recovering elemental sulfur to get clean biogas. It's mostly we have upgraded biogas most of all, and for this using also some nutrients that can be effective use for bacteria's growth. It can be in liquid phase nutrients, or we can immobilize it, this bacteria in some mineral carrier. And estimation some of factor optimization parameters as it depends on hydrolytic rate time for this process and controlling strategy of selection. It also can be possible for optimization some nutrients ration in bioreactors, etc. Also a lot of investigation, some expanded granules of sludge that can also use in system biofilter flooding, and how it's impacted for removal sulfides and recurrent elemental sulfur now present in the different type of research. That all of this information, all of this type of techniques, research and industrial implementation go to adaptation to climate change's integration system, to developing energy, to waste recycling and production some biobasic products, possibility of modeling and removing hydrogen sulfide from biogas, have some more information for scaling this processing, and mostly involving new type of granular carriers, also important, involving new type of feedstock, sustainable feedstock. That we mean for sustainable feedstock is can be possible secondary resources, some waste involved into this, useful components of waste, also very important analysis is opportunities. And verification as can be possible adequate analysis of the states and opportunity of implementation such type biotechnologies. So of course, when we tell about mobilizing materials that can be used, it's a lot of type of such materials. It's called some of how to say heterogenic biocatalysis based on absorption bacterial cells. Activity of this carrier can be estimation of dominance genera species, and the activities that can be estimation also for different type of medium, different type of materials. Most basic type, it's using some of active carbon felt, some of type of solid, some minerals that can be used, some of synthetics, polymers, also polymer fiber can be used, and can be involved in some new type of mineral how to say supply or immobilizing materials that can be involved with new type of sustainable feedstock. And now a lot of investigation are also focused to involve more sustainable feedstock to these systems that minimization use natural resources. So it's now, how to say, trends to analysis opportunity of involving different type of waste, byproducts as sustainable feedstock for growth, technology innovation and growth level of sustainability of technology in general. So it's a last slide of this presentation should be mentioned. We have also one access presentation that I have I think to discuss now. Also, we have time for this, and I think its information can be useful for mostly analysis opportunity of anaerobic digestion, different aspect, different waste recycling. So I mentioned about this more. And then let's see, maybe it will be final today of our lectures. Okay, some moment. Yes, this type. Basics elements, mostly I mentioned that if we have time, I tell more about documentation, and this presentation have some of more details of such biological treatment. It's interesting to tell about this because now it's a lot of tell about documentation. And also we mostly tell about wastewater and sewage sludge. Opportunity to anaerobic digestion for such type of feedstock is how to say have such different features of feedstock and different type of contamination that impacted of anaerobic digestion, and we mostly discuss the possibility to involve with some detoxification processes for anaerobic digestion, especially precipitation heavy metals using hydrogen sulfide. But now it's more basic, we step by step involving. If we have time, it will be useful to tell about this, and we, how to say, briefly tell about waste as sustainable feedstock in different way, and some moment of dark fermentation. Other aspects mostly we discuss. So can be tell about different type of feedstock. Also, a lot of feedstock it's involved in agricultural sectors, and of course, when we tell about municipal waste, also separately collected this waste, we can use food waste, organic waste as substrate for anaerobic digestion and to get some useful products. And also when we tell about adaptation to climate change and adaptation technologies, it's important to mention this technology to estimation greenhouse gas emission, for example, from anaerobic digestion for waste and decomposition. This is some of investigation effects for anaerobic digestion with comparison conventional manual decomposition, and also we can see some of priority of methane emission waste, and how we can this emission, how we can conversion gases and get more profits for us and storage carbon soil. So it's a set of present investigation that provide now information about anaerobic digestion and biogas technology as adaptation technology and such adaptation to climate change. Of course, this feedstock can be very different, and we tell about elements of biotechnology, about pre-treatment, about intensification, anaerobic digestion, and method of this intensification to get some more benefits in anaerobic digestion for increased level of biogas, yes, reduction some harmful components, etc. And after this basic stage, we have post-treatments for separate biological products and to get this product in more volume-added forms. And global benefits are connected with reduction consumption fossil fuels, some of how using biomasses, including bioorganic waste and renewable resources, and no carbon fruits into atmosphere. So it's some climate protection system. Also, when we tell about digestat, it's important to announce this opportunity to use digestat in agriculture and for remediation processes. For support soil remediation, it's also important, and some of type other environmental benefits for local territories, connection with waste storage and deposit, with soil fertility rehabilitation, and possibility solving some number of sanitary and hygienic tasks. So it's also important to reduction pathogenic components in waste, and some target investigation now about digestat from mesophilic and thermophilic condition that we get. Mesophilic condition also it's around temperature 35 Celsius degree. Thermophilic condition is around 55 Celsius degrees. So different temperature regime impact to quality of digestat that we get, and the most important, all pathogenic components is death or not, and this is also very important for the digestat that we can use in agriculture. Also, we can compare some opportunity for anaerobic digestion comparison with aerobic treatment, because we can tell. It depends, of course, with organic loading, and in some processing more better use anaerobic digestion, some with some wastewater better aerobic treatment. Sometimes it's very useful to use two-state with combination aerobic and anaerobic treatment. So according to the organic loading. Nevertheless, we can tell some benefits of anaerobic digestion. It's forming less sludge, also possible to generation energy, and we don't need energy demand for aeration. Of course, for anaerobic processing, should be some constant temperature in bioreactors in the methane tank. Yes, some constant temperature, and it's also necessary to supply energy, but it can be from biogas this energy get. To provide this constant temperature, and also it depends of regions and climate condition. Especially we can see that now waste as resources, as sustainable fertilizer, sustainable feedstock sustainable feedstock. Sorry, waste now is discovered a lot, estimation investigation a lot, and this trend we can see step by year. It's really increased incredible use investigation waste as resources for anaerobic digestion, and different countries involved into these processes. Because it's mostly now a lot of discussion to how to say this category of waste. It's not effective category that we need thinking that it's not waste as unuseful something, but it's really useful components that can be recycled, so it's sustainable feedstock. So as a thinking and not to use this term waste. But most of all, this sustainable feedstock, mostly it's different type of waste, but it's as a thinking about this waste. And this category of opportunity of using such sustainable feedstock in biological treatment to get some products. For example, we can tell about some animals and mixed food waste, how we can use this type of biodegradation, organic waste, complexes biodegradation, some of a type of sludge, some of salt residents, some industrial effluent sludge also involved into sustainable feedstock. This effluent sludge, how to say, they mostly can have more big some contaminations than other type of sustainable feedstock, but it's interesting to involve in some of industrial sludge to anaerobic digestion and to get more benefits from this type of waste. And of course, investigation of influence waste type to quality to quantity composition often important, and a lot of investigation of rate comparison with how it can be possible to combination this type of feedstock and what level of biogas production we can get from 1 kilogram of dry matter for this type of feedstock, and difference investigation we can now see in this way, an analysis solid, total solids and volatile solid for how to say investigation, aerobic digestion, and some summarized difference research do, because it's a parameters that can be estimation for comparison difference research results, and analysis some common features and some difference between results of different research schools. It's mean institution and laboratories, and soon implementation in industry can be different way. Now also a lot of laboratory in the university, in institutes in the European Union, they have strong cooperation with the company for estimation, testing substrates, different type of substrate, different type of sustainable feedstock, waste, yes, how it's impacted for biogas production, what's most important parameters that can be optimization for anaerobic digestion. This feedstock should be used, and this is a collaboration very important for implementation, some laboratory investigation, some substrates to industry, and company interested to involve in new type of feedstock and estimation quality of this feedstock for anaerobic digestion, and this can be helpful for laboratory research and soon scale into industry. So that connection very important for implementation in practical such type of research in different way, in different type of combination to estimation bagasse level production, quality, etc. So we don't mention a lot about this briefly because I won't tell you something about dark fermentation also. We have for this time and estimation humidity from materials load in barracks are also important analysis because it can be impacted also gas fermentation. And also we tell about some ratio of nutrients that present in this feedstock, and it's important for bagasse production. It's a carbon-nitrogen ratio and some optimal ratio mostly now identified, determined, and mostly it should be optimization dosage of different substrates to get this optimal ratio. Combination can be mixing ratio, can be difference. pH also can be difference. If you see this natural pH, but also the philic pH can be, or using, yes, sometimes also pretreatment can be different. So it depends on substrate that we have, and if it's a lignin cellulose substrate, also pretreatment it requires for more biodegradation opportunities. This substrate useful for microorganism. So a lot of type of pretreatment can be possible in optimization, composition of substrate, this sustainable feedstock that can be interesting to get some more optimal nutrients in biofertilizer also. As a general scheme, should be mentioned about dark fermentation. I tell about this because it's about biohydrogen production, and it's also in anaerobic condition. So, but of course, it can be biological process in anaerobic condition. It's anaerobic fermentation. Also, we can involve it photofermentation, but it's the other way. And biological hydrogen production have different biological processes that can be involved. Bioelectrolysis, also bioelectrolysis, microbiological electrolysis cells can be involved, and photofermentation can be involved, etc. But mostly I won't tell about dark fermentation because it's connection with anaerobic condition and anaerobic digestion. How it's connection, we can see in this slide. For example, you see state by state. Yes, we have substrate, they go to state hydrolysis, then acidogenesis, then methanogenesis. Yes, it's a general anaerobic digestion. But if we take phases hydrolysis and acidogenesis, it's go to dark fermentation. So part of state of anaerobic digestion, when we not continue to terminal state, not go to methanogenesis, I stop in acidogenesis, it's our dark fermentation, because in acidogenesis we get not only volatile organic acids, but also hydrogen. So this also can be very useful products. Hydrogen is biofuel also can be, and also organic acid can be very useful byproducts, and now it's a lot of use in this type of volatile fatty acid, and it can be used for biopolymerization, biopolymers composition production. So it's a lot of different applications. So we can stop it in acidogenesis and go to dark fermentation for these products. Sometimes it can be, and also this implementation a lot in Germany now. It's very interesting in hydrogen production and green hydrogen production and biohydrogen production. So in dark fermentation, they're very interesting. For example, in the European Union, I know, and it's a lot of discussion of opportunity of this. And also it can be combination with anaerobic digestion when we separate different state. It's also can be involved. For example, cause acid organic fermentation. When we tell about dark fermentation, it can be called also acid organic fermentation. We can get the hydrogen, but this hydrogen also it depends on what we want. Sometimes it's combination with methane production. So it depends of techniques and a lot of discussion what's better, hydrogen as a clean energy sources, or we can use the hydrogen for methane production, etc. So it can be different technological solution, most of all. And mostly when we purification by gas and go to reform, we can get hydrogen. So combination of technological solution can be very different for this way. Mostly what it should be mentioned, some short presence of bioinformatic databases. Mostly it can be useful if some of you have some microbiological background and use bioinformatic base dates can be interesting in research and analysis metabolic pathway, for example, for methanogenics arrays, also interesting selection under selection microbial culture, and we also can analyze this pathway for involving enzyme treatment. And this databases, genome databases, is a Japanese database, is also very useful and have very interactive interface with very detalization each reaction. So I recommend it if you have such background and you interested in microbiologic field, you can use this database. More details I can give for some person if if some person want to more details have for this type of databases. Also get databases interesting in this way because we can estimation all the chemical reaction and metabolism of bacterial group, microorganism groups, and mostly analysis opportunity for intensification process of methane production, for example, methane production. So it can be interesting. And finally, we discuss in these slides, and mostly now it's all-time discussion in different way about environmental protection. Environmental protection field about adaptation to climate change. Yes, all of this discussion and mostly different technological solution have estimation and these factors involved into protection ecosystem and to support ecosystem service. Mostly we can analyze how anaerobic digestion and dark fermentation can be useful in focus of environmentally friendly processing of different type of waste as sustainable feedstock. So possibility mix different type of sustainable feedstock to optimization processing process to production useful bioproducts. Also possibility to increase level of production energy resources as renewable energy resources, such as biomethane. We tell for upgrading biogas to biomethane, and we'll also tell about biohydrogen. So it's a type of biofuels that also involved to decrease greenhouse emission. Also useful to get some type of environmentally friendly fertilizer that can be involved into agricultural sectors and also involved into remediation soil. And this fertilizer more friendly and minimization chemical involved into agricultural chemical fertilizers, basic chemical pesticides. So it's such direction also can be tell about opportunity for decrease some of traditional technogenic factors and possibility to involve in minimization involving natural resources. Also to involve in sustainable feedstock as secondary resources. Also, we can tell about energy efficiency processing and the opportunity for possibility to estimation carbon footprint. In European Union, it's a lot to tell about footprint family and especially in carbon footprint. So a lot of technological solutions have such type of estimation, and mostly it's all-time discussion and all-time in different type of project. Mostly when we tell about some research ecosystem, how to say that growth in university institutes in the European Union. It's mostly such systems that necessary applying in different level of grants to get a lot of funding for support for some projects should be to get, and it's all time some high level of concurrence to understanding the most important factors of technology solution, innovation solution, how it can be implementation in practical combination with some current technologies, and to involve in some industry partners, also very important. And this is processing all time is growth, and some periods of grant application is most basic periods that can have, how to say, to understanding only this type of activities. Grants activities is a basic type of work in research field in European Union, and also mostly cooperation with industry. So it's some other model of analysis of research activities, not only basic in some investigation in laboratory, but possibility to get funding from different type of grants with cooperation with industry. So it's mostly such type of supporting such research activities now is activated in European Union. Also, we can tell about some environmentally friendly technologies that can call it adaptation technologies. It should be monitoring in each level of emission, different type of gases, different type of other emissions that can be come from technological state by state, from involving some raw materials to get some final products, and mostly accent to involving not natural resources but sustainable feedstock. So in this way, we can tell that biogas technology and anaerobic digestion is a real example of realization adaptation to climate change technologies and sustainable technologies. And mostly these biobasic products that can be get the estimation also as environmentally friendly products that can be very helpful for us as human and very interesting to support economic growth as a bioeconomic. And also we tell about environmental benefits that we can get from these products, biobasic products. So this is mostly important that I want to mention about anaerobic digestion and dark fermentation. It's the general production by biogas, especially to upgrading biogas to get biomethane, and also we tell some shortly briefly about biohydrogen. We have several minutes. I can also mention that implementation biogas station in solid waste landfill also have some applications and a lot of research and industrial implementation done in the European Union. And it would be mentioned that this municipal solid waste landfills, they have different years old, most of all, and in different years, in massive of this solid waste, generate biogas with different composition. It's also very important to estimation this rate, this how to say connection between biogas composition and years of landfill, and mostly we can choose the most optimal period of time that to get biogas from this municipal solid waste landfill with most bigger production methane. And mostly it's an interesting way for get good quality of biogas from municipal solid landfill, but it should be estimation some parameters of this biogas production according to the years, and also upgrading biogas necessary. It's that type of reflection for using different type of waste, different type of organic waste as a basic substrate for digestion, and also we can mention about different mineral addition for stimulation aerobic digestion, and different technique for this type of treatments. It's a final of our discussion now of lectures. I hope it's this information interesting for you. It's